Okay, last time we have completed LDA and 1,3-dithene. Now today we are going to discuss about the another reagents. Today we will try to complete the two reagents. Names are sodium cyanoborohydride and one more is DDQ. You have heard about the lithium aluminum hydride, which is known as a reducing agent. You have also heard about the sodium borohydride. That sodium borohydride is also known as a reducing agent. Lithium aluminum hydride and sodium borohydride, both we can use for the reduction of carbonyl compound, especially when ketone or aldehydes are present. So if you are having ketone, then ketone by the reduction with LiAlH4, that is called lithium aluminum hydride, or sodium borohydride, we will get alcohol. If we are having ketone, then we will get secondary alcohol, and if we are having aldehyde, then we will get primary alcohol. So conversion of carbonyl group into alcohol we can carry out with the support of lithium aluminum hydride or sodium borohydride. Both are the well-known and industrially important reagents. Today we are going to discuss about a reagent. Its name is sodium cyanoborohydride. Sodium cyanoborohydride is also known as a reducing agent, but it is little bit different, or have its reactivity is different than lithium aluminum hydride and sodium borohydride. The reason is presence of cyano group. But which before starting the discussion about the what is the role of cyano group, we should understand the chemistry of boron. As we know, atomic number of boron is 5. So the electronic configuration is 1s2, 2s2 to p1. If we go for the hybridization, in the hybridization we are having sp3 hybridization. Here sp3 hybridization is there, but we are having three orbitals. Those are known as half-fill orbitals, and one orbital is vacant. So as per the hybridization and as per the electrons available in the excited state in the outermost shell, there are three electrons, and due to the presence of three electrons we can say boron can form three bonds. So here boron has formed three bonds with hydrogen, but boron is having one more orbital that is known as vacant orbital. Cyanide Cn- which act as a nucleophile and having tendency to donate electron to boron, boron accepted those electrons in its empty orbital, and that's why BH3Cn-. So boron is normally, if we are talking about BH3, then there is no charge, but when it is converted into BH4 or BH3Cn, means 4 valency on of the boron. When boron having 4 valency, at the time we have to write negative charge or minus. That negative charge is neutralized by sodium, that is called Na plus over here, sodium ion or Na plus here. Now we are going to discuss about how it is useful for the reduction and how it works and why it is different than BH3 and why its reactivity is little weak, or it is a weak reducing agent as compared to the uh, BH4, that is called sodium borohydride. Here the presence of the Cn. Cn, cyano group having tendency to pull electron. As we know, nitrogen having higher electronegativity, that's why nitrogen will pull electron from the carbon, and that's why nitrogen become negative. So carbon become positive. Now carbon will try to pull electron from the boron, and boron don't have electron, but boron having electron in coordination, or electron when it having a bond, or boron is having an electron which is shared with hydrogen. So three hydrogens are here. So these hydrogens are slightly or bond electron between hydrogen and boron slightly migrating or towards the boron, and as a result this hydrogen will be eliminated as a H plus, and then after the further reaction will take place. So due to this reason, or due to the presence of cyano group, what happened? The reactivity of BH3CN is slightly lower as compared to BH4. In BH4 easily H minus is available and a further reaction will take place. So the sodium cyanoborohydride will not attack directly on ketone. Suppose if you are having ketone, then direct reaction between sodium cyanoborohydride and ketone will not take place. Where if you are having lithium aluminum hydride or sodium borohydride, the reaction will take place. But if we are going to treat this compound that is called ketone by sodium cyanoborohydride, the reaction will not take place. So that what we have to do? We have to treat this compound first with the amine. When it react with amine, it will convert it into imine. And then after imines will react with sodium cyanoborohydride and it will convert it into amine. So ultimately what we can say, in this reaction what happened? In this reaction first amination reaction is take place and then after the reduction reaction is take place. So two reactions are simultaneously take place in this reaction. That's why it is known as reductive amination reaction. It is known as reductive amination reaction. Why? As I said, in this reaction amination is take place. Here you can see nitrogen is introduced, so amination is take place, and at the same time hydrogen is also introduced, so reduction is also take place. So two reactions are take place in this with the support of this one reagent, so it is known as reductive amination reaction. Here in this reaction you can easily understand, we are having RC double bond OI, that is called ketone. If R equal to methyl, then we call it ketone, and if one R equal to methyl, another R equal to H, then we can call it aldehyde. This ketone or aldehyde react with amine. First of all, it will convert it into C double bond N, that is called imine. Once we are having imine, then after by treatment with sodium cyanoborohydride, we will get this compound. Okay, here you can see it is a conversion of imine to amine. Here two hydrogens are introduced. So it is called reductive amination reaction. Now how the reductive amination reaction is take place, we can understand by mechanism also. But instead of going into detail, we can easily understand by the easily understand by this reaction. Here you can see oxygen is replaced. Okay, first of all removal of water molecule will take place and it will convert it into C double bond N, and then after we are having this compound. Then this sodium cyanoborohydride is also useful for the reduction of oximes. Now how we can generate or how we can prepare oxime? Here we are having in the beginning we are having the compound that is called ketone. So CH3 C double bond O CH2 CH3, and then after by treatment with NH2OH, that is called hydroxyl amine NH2OH. When we treat this compound that is called ketone by hydroxyl amine, we will get this compound C double bond NOH. In this compound we can call, or this group is known as oxime. The C double bond N OH is known as oxime. Now this oxime by treatment with NaBH3CN, sodium cyanoborohydride, here we can see CH3CH NHOH. So we have introduced two hydrogen. We have also introduced the nitrogen. That's why it is known as reductive amination reaction. As I said, if we have ketone, that ketone react with secondary amine. If we treat this ketone with primary amine, we will get C double bond N, that is called imine. And if you are treating this compound, that is called ketone with secondary amine, when we are treating this ketone with secondary amine, we will get amine cation, imine cation. This imine cation, by treatment with NH3BC, NaBH3CN, sodium cyanoborohydride, we will get tertiary amine. Here you can see R, R and C. So tertiary amine we will get. If you are treating this ketone with substituted hydroxyl amine, then we will get uh, this intermediate first, and then after by treatment with NaBH3CN, we will get this product. So here we have introduced nitrogen and here we have introduced hydrogen. So we can call this a reductive amination reaction. Same way other compounds we can prepare. Now the question is how the reduction is take place by NaBH3CN. So as per the mechanism, first of all, what happened? As we know the characteristic of carbon and nitrogen will pull electron. Okay, when nitrogen will pull electron, first of all, nitrogen will gain negative charge and this carbon will gain positive charge. Now from NaBH3CN, okay, from NaBH3CN, as we have discussed, cyano group having tendency to pull electron, and that's why one H will be eliminated as a H plus. That H plus will bind over here, and then after second H will be uh, will be eliminated as a H minus, and second H will bind over here, and we will get the product. Now next one is DMP, Martin per iodine. In DMP, as we have discussed about the reduction, in the reduction we can introduce hydrogen. So now DMP we are going to use for the oxidation reaction. So as per the definition of oxidation, oxidation means addition of oxygen. Second is removal of hydrogen. Third is increase in oxidation number. And fourth one is release of electron. So these are the four definitions of oxidation. For carrying out oxidation, we require normally KMNO4, K2Cr27, Na2Cr2O7, CrO4 like oxidizing agent. But when we use this type of oxidizing agent, at that time, oxidation reaction will take place, but it gives the various salts of Mn, various salt of chromium. The salt of Mn and chromiums are highly toxic for the aquatic life, and that's why we have to stop use of this kind of toxic compound. So what are the other alternatives? So we can go for the organic oxidizing agent, and this one is DMP, is known as the oxidizing agent, which is known as organic oxidizing agent. But when we are using DMP, okay, we have to take care, or some precaution we have to uh, take during the use of the DMP. If we don't take care, or if we don't maintain the guideline, or if we don't follow the steps given for the precaution, then accident or explosion may take place. So we will discuss what kind of accident or explosion may take place, or what type of precautions we have to take when we are using DMP. Instead of DMP, other reagents are also there. The name of the reagent is Swan's reagent or Swan oxidation. Now in the Swan oxidation, what we require? we require DMSO and dichlorodiketone as a reactant. If we use this reactant, then we can carry out the oxidation reaction. If we are having primary alcohol, then by oxidation we will get aldehyde, RCH. If you are having aldehyde, then by oxidation we will get acid. In the first one reaction, here the reaction is taken place or reaction is carried out by Swan oxidation. During this oxidation, we have converted aldehyde, that is called primary alcohol, to aldehyde. But during this reaction, dimethyl thioether, carbon monoxide, carbon dioxide, and HCl are generated. These all are toxic or poisonous in nature. In the second reaction, oxidation of aldehyde with amine. When we are carrying out oxidation of aldehyde with manganese or amine containing salt or compounds, here amine 7 means K-amino4 is used. K-amino4, when we use, the oxidation reaction will take place. So aldehyde will convert it into acid. But with this reaction, salt of amines are formed. When salt of amines are formed, that is called oxide of amines are formed, those oxides are toxic for the. Here we are going to now discuss about DMP, how we can prepare. If you are having antranilic acid, we are very much familiar with the Sandmeyer and Ketterman reaction. If you are having primary amine, then we can easily introduce halocene via the pathway of diazotization. Here we are having antranilic acid. This antranilic acid, by treatment with NaNO2 plus sulfuric acid, we will get diazonium salt, that is called N double bond NHSO4 minus we will get. Once we are having diazonium salt, that is called N double bond NHSO4 minus, then after by addition of Ki solution, potassium iodide solution, we can introduce I over here. So now we are having iodobenzoic acid. This iodobenzoic acid, by treatment with KBRO3, it will convert it into IBX. It's a name of compound, but IBX is known as explosive material if it is in a dry form. So immediately we have to introduce acetic anhydride for the acetylation reaction. When we carried out the acetylation reaction, now we are having the compound, its name is DMP, Des-Martin per iodine. But this compound is also, we have to handle it properly. This compound is heat sensitive, so we should not uh, give temperature or apply temperature greater than 130 degrees centigrade. Second thing, it is a shock sensitive. So whenever we are traveling or transporting the material, we have to take care. There is if shocks are there, means vibration or shaking is there, then what happen? Intermolecular reaction will take place, and due to the friction of molecule, heat will generate and it may explode. So these type of precautions we have to take care whenever we are using this compound, that is called DMP. Otherwise, DMP is a good oxidizing agent and well-known oxidizing agent for the industrial manufacturing. How it works? DMP. Now we are going to carry out the oxidation reaction of alcohol. Here we are having secondary alcohol. Secondary alcohol, when we are treating with DMP, oxidation reaction will take place and we will get ketone, C double bond O CH3CH3. We are having ketone and this compound will form. It is a byproduct, but when we carried out the further acetylation reaction from this compound, again we will get DMP. This is the advantage of this reaction. Here another example, or we can say first we discuss about the another example if we have. Okay, another example. Here you can see it's a primary alcohol. Primary alcohol by treatment with DMP or Des-Martin reagent, then it will convert it into aldehyde. So what we have discussed? We have discussed that if we are having secondary alcohol, then by treatment with DMP we will get ketone. But if you are having primary alcohol, then by treatment with Des-Martin reagent, we will get aldehyde. So this is the usefulness or importance of this oxidizing agent. How the reaction mechanism or reaction will take place? First of all, DMP react with alcohol. Here the simple or minor conversion will take place from OH, alcoholic OH, removal of hydrogen, and from here removal of acetate ion, that is called Ca3 C double bond O. So H and acetate ion react with each other and it will convert it into ACOH. This ACOH when convert at that time here valency means the oxygen is attached with this I, and as a result we will get IOCH R dash R. Okay. After that, further only the electron shifting will take place, and as a result another acetic acid will be eliminated. How it take place? Here we can see I will pull electron from oxygen. Why it pull oxygen giving electron? Because oxygen is attached with the hydrogen. So oxygen having higher, oxygen is attached with the carbon and carbon is attached with the hydrogen. So oxygen having higher electronegativity, therefore it will pull electron from the carbon and carbon will pull electron from the hydrogen. This is the first case. Second thing, here next to this hydrogen, there is a oxygen which having lone pair of electron. So here in the attraction between oxygen and hydrogen take place, and as a result this oxygen will give electron to the hydrogen and ultimately this hydrogen will be removed as a H plus and finally it will convert it into Ca3 C double bond OH. So acetic acid will form. Then after the further electron will transfer over here and then after on I. So we will get the oxidation of alcohol, oxidation of secondary alcohol, and that's why we are having here ketone R C double bond O R dash. Some other reactions are now here looking to the structure. It looks a complicated structure. We are having two hydroxy group or two OH group. Here OH group and here another OH group. But if you compare the characteristic of both the OH group, both are different. This is in the form of CH2, CH2, CH2OH. So we can call it as a alcoholic OH. This is attached with the ring and ring having aromatic character. So this OH is known as a phenolic OH or aromatic OH. Okay, this OH is known as aromatic OH or attached with the aromatic ring. Here, this OH is attached with aliphatic or hydrocarbon only or open chain. So we can call it a alcoholic OH. As per the characteristic of DMP, DMP will react only with the alcoholic OH group, and that's why here we will get the product that is called CH2CH2CHO. So conversion of this will take place, that is called alcoholic OH will take place, and there is no effect on the aromatic OH. So this is called selectivity of the reagent. Here another compound in which we are having OH, but OH is attached with the cyclic ring, but this ring is not an aromatic ring. When ring is not an aromatic ring, it means it is a non-aromatic OH. So when we are having this kind of OH, that is called alcoholic OH, here cyclic alcohol. So alcoholic OH group is there, and that's why by the oxidation or by using DMP, we will get the product. And here we will get the ketone. Why ketone? Because here this OH is secondary in nature, and that's why we are having ketone. So looking to these reactions, one thing is very much clear, that if you are having primary alcohol, then you will get aldehyde. But if you are having secondary alcohol, then you will get a ketone. Here another complicated structure. In this structure you can see OH, that is called Ca2OH. So your focus should be on this position only. So by treatment with DMP, that's Martin reagent, what we will get? Here primary alcohol is there, so we will get aldehyde. So I think it is clear to all. If you are having secondary alcohol, then by treatment with Des Martin, we will get ketone. If you are having primary alcohol, then we will get the aldehyde. Now another reagent, its name is DDQ. DDQ is also known as the reducing agent, sorry, oxidizing agent. But here role of DDQ is little bit different as compared to the DMP. DDQ is well known for the dehydrogenation. Hydrogenation means addition of hydrogen H2, and dehydrogenation means removal of hydrogen H2, removal of H2. So let's say example, if you are having alkane and if you want to prepare alkene, then you can use DDQ. Removal of hydrogen is also known as oxidation. Here same thing we are doing. We are removing hydrogen, and that's why we can call it a oxidation. But here we are removing two hydrogen, that is called H2, from the adjacent carbon, and that's why it is known as dehydrogenating. So the DQ is known as powerful hydrogenating agent. Means with the support of DDQ, we can remove two hydrogen, that is called H2, from the compound. How it works? We can see here DDQ. Suppose this is an aliphatic compound, okay, or alkane. By treatment with DDQ, two hydrogen will be replaced, so it will convert into OH. This one is converted into OH. When it converted into OH, so we will get DDQH2. Now this DDQH2 is insoluble in most of the organic solvent. So after completion of the reaction, just we have to filter it. We can remove the DDQH2, and then after we can collect our product from the filtrate. So initially what we had alkane. Now we are having alkene. That is DDQ. DDQ we can prepare from quinol, 1,4-di, sorry, 1,4-di quinone. Here this one is the quinone, but quinone we can prepare from quinol, 1,4-di quinol. In 1,4-di quinol, previously it was here OH are there, then we can call it quinol, and when it oxidizes, it converted into C double bond O, it is known as quinone. Now this compound, by treatment with HCN, first of all the addition reaction will take place, and as a result CN we can introduce. Then after further oxidation we can again get we are having quinone derivative. This quinone derivative, by further treatment with HCl, it will again the addition reaction will take place, and due to the addition reaction, we are having now halogen into the ring, and then after by further oxidation we get quinone derivative, and this quinone derivative finally by treatment with HCl we can introduce one more halogen, and finally further oxidation we will get the quinone or quinone, that is known as DDQ. DDQ compound we have prepared. As we have discussed, DDQ is known as dehydrogenating or dehydrogenation reaction we can carry out with the support of DDQ. Suppose if you are having cyclic compound, but this cyclic compound is not an aromatic compound because we are having only two bonds. If you wish to convert this non-aromatic compound into aromatic compound, then with the support of DDQ we can do. So when we carried out a reaction by DDQ, then what happened? First of all, in DDQ resonance we can observe. Why the resonance we can observe? Because oxygen is attached with a carbon having double bond, then after single bond, double, single, double. So conjugation of bonds are there. Whenever the conjugation of bonds are there, then immediately what happens? Resonance we can observe. And due to that resonance effect, oxygen will pull electron to another end, or at the another end oxygen become positive. When oxygen become positive, from here hydrogen will be transferred or eliminated as a H minus, and as a result here carbon which having positive charge, carbocation will form. Now carbon having positive charge, so carbon will pull electron from its neighboring carbon, and neighboring carbon will pull electron from the hydrogen. Now, as a result, this electron will migrate over here, and as a result what we will get? Aromatic. So if you are having non-aromatic compound, then we can convert into aromatic compound with the support of DDQ. So it is known as dehydrogenation reaction. Here we are having one compound. Here we are having two rings. Whenever we are having two rings, as per the Hückel rules, it should be 10 pi electron. But here 6 pi electrons. So we cannot consider this compound is aromatic in nature. Okay. So when it is not an aromatic in nature, and if you want to convert it into aromatic compound, then by treatment with DDQ we can carry out the reaction. So from here two hydrogen will be absorbed first by DDQ, and then after two more hydrogen will be absorbed by the DDQ. So here 2 moles of DDQ required, and ultimately we will get naphthalene. Now here you can see 10 pi electrons are there. As per the Hückel rule, if two rings are there, then 10 pi electrons are required. So here 10 pi electrons are there. So we can say this one is known as aromatic compound. This one is a heterocyclic compound. Here also the conjugation of double bonds are not there. Due to the non-conjugation of the double bond, we cannot consider this compound as a aromatic heterocyclic compound. This one is heterocyclic compound, but it's not a aromatic. So what we have to do? We have to carry out the reaction by DDQ. When we carried out the reaction by DDQ, the dehydrogenation will take place, and then after we are having now double bond. And here lone pair of electrons. So 10 pi electrons are available. So it will convert it into aromatic compound. Some other examples are there. Here we are having conjugation, and here we are having CH2 CH2. So by treatment with DDQ we will get double bond over here. This reagent is also useful for the preparation of some heterocyclic compound or cyclization reaction. How it works? So here COOH means hydrogen is here, and here also hydrogen is here. So by treatment with DDQ, removal of hydrogen will take place, and we will get the cyclic compound. So some more reaction we can carry out with the support of DDQ. So today I have discussed about the three reagents: DDQ, then DMP, and previously I have discussed about sodium cyanoborohydride. Sodium cyanoborohydride we can use for the reduction, but not for the reduction of ketone and aldehyde, but it can be useful for the reduction of imine, imine cation, and oxime. Then we have discussed about the DMP. DMP is known as oxidizing agent. DMP we can use for the oxidation of secondary alcohol and primary alcohol. If we are having secondary alcohol, then by oxidation we will get ketone. And if we are having primary alcohol, then by oxidation we will get aldehyde. Then last one we have discussed, that is DDQ. In the DDQ it is also known as oxidation reaction, because removal of hydrogen is known as oxidation reaction, but here the more preferable word is DDQ is known as powerful dehydrogenating agent, and with the support of DDQ we can carry out reaction on aliphatic cyclic compound, where we can generate unsaturation. Unsaturation means we can introduce double bond between two carbon by removal of hydrogen, that is called H2. So we have discussed about three reagents. If you have any question and or query, then you can ask me. Yes, Shreyans.
હેલો સર.
Hmm.
સર ડેસ માર્ટિન ઓક્સિડેશનમાં આપણે જે સેકન્ડરી આલ્કોહોલ લઈએ છીએ
Hmm.
એમાં સર OH અબવ ધ પ્લેન ઓર બિલો ધ પ્લેન હોય તો પર્સન્ટેજ યીલ્ડમાં કોઈ ફરક પડે?
ના, પર્સન્ટેજ માં કોઈ ફરક ન પડે. એ ખાલી આલ્કોહોલિક OH હોવો જોઈએ.
ઓકે.
બીજા કોઈને ક્વેશ્ચન હતો? યસ, ખુશ્બુ.
સર સપોઝ આપણી પાસે કોઈ એક કમ્પાઉન્ડ છે, એમાં બે સેકન્ડરી આલ્કોહોલ છે અને એક પ્રાઇમરી આલ્કોહોલ છે, તો ડિસમાર્ટિન થી ત્રણનું ઓક્સિડેશન થઈ જશે સાથે જ. ત્રણ આલ્કોહોલિક હોય તો.
આલ્કોહોલિક OH થઈ શકે.
તો કોઈ આપણે કોઈ પર્ટિક્યુલર એક જ આલ્કોહોલિક OH નું કરવું હોય તો આપણે આ યુઝ ના કરી શકીએ ને?
શું?
ડિસમાર્ટિન રિએજન્ટ છે, કોઈ એક જ આલ્કોહોલિક OH નું ઓક્સિડેશન કરવું હોય તો યુઝ ના કરી શકીએ ને આપણે આ?
હા, હવે કોઈ પણ રિએક્શન છે, એના રિએક્શન તમારે જો કંટ્રોલ વેમાં કરવું હોય તો ટેમ્પરેચર ફેક્ટર થાય. તમે નોર્મલ રૂટીન રિએક્શન કરશો તો એ બંનેનું કરી નાખશે. તમે જે કીધું કે સિલેક્ટિવલી કોઈ એકનું કરવું છે, તો એના માટે તમારે એ જોવું પડે કે આલ્ડીહાઇડ અને કીટોન એ બેમાં રિએક્ટિવિટી કોની વધારે છે. બરાબર? તો આલ્ડીહાઇડ અને કીટોનમાં જેની રિએક્ટિવિટી વધારે હશે તે પહેલાં રિએક્ટ થશે, અને જેની રિએક્ટિવિટી ઓછી હશે એ સેકન્ડરી થશે, એટલે કે એના પછી થશે. એ કંટ્રોલ કરવા માટે આપણે ટેમ્પરેચર મેન્ટેન કરવું પડે. લો ટેમ્પરેચર રાખીશું તો જે મોર રિએક્ટિવ ગ્રુપ છે એ પહેલાં રિએક્ટ થશે અને લેસ રિએક્ટિવ ગ્રુપ એ પછી રિએક્ટ થશે. હવે તમને એમ થશે કે બેમાંથી રિએક્ટિવ ગ્રુપ કયું વધારે? તો આલ્ડીહાઇડ એન્ડ કીટોનમાં આલ્ડીહાઇડ એ મોર રિએક્ટિવ છે, ત્યાર પછી કીટોન. આપણે આઈ થિંક સેમિસ્ટર 1માં પણ આખી એક સિરીઝ બતાવી હતી મેં, કે રિએક્ટિવિટી ઓર્ડર ઓફ કાર્બોનિલ ગ્રુપ્સ. તો કાર્બોનિલ ગ્રુપ જેટલા પણ કમ્પાઉન્ડમાં આવે છે, કાર્બોનિલ ક્યાં ક્યાં આવી શકે? આલ્ડીહાઇડ, કીટોન, એસિડ, એસ્ટર, અમાઇડ. બરાબર? આ બધામાં કાર્બોનિલ જ છે, સી ડબલ બોન્ડ O જ છે, પણ દરેકમાં કાર્બોનિલ ગ્રુપની રિએક્ટિવિટી જુદી છે. તો આલ્ડીહાઇડ એ મોર રિએક્ટિવ છે, ત્યાર પછી કીટોન, ત્યાર પછી એસ્ટર, ત્યાર પછી એસિડ, ત્યાર પછી અમાઇડ, એવી રીતના આખો ઓર્ડર છે. હવે તમે જે કીધું એ પ્રમાણે તમારે સિલેક્ટિવલી આલ્ડીહાઇડ સોરી એક જ ગ્રુપને રિએક્ટ કરાવવું હોય તો તમે ટેમ્પરેચર ડાઉન કરો એટલે રેટ ઓફ રિએક્શન ઘટી જાય. રેટ ઓફ રિએક્શન ઘટે એટલે કંટ્રોલ વેથી તમે રિએક્શન કરી શકો. ઓકે ખુશબુ,
ઓકે સર.
બીજા કોઈને ક્વેશ્ચન છે? ઓકે, તો આઈ થિંક 7 થી 8 આપણા રિએજન્ટ્સ છે એ પૂરા થયા છે. આઈ થિંક કે 10 કે 11 છે. તો જે પણ બાકી છે નેક્સ્ટ ટાઈમના લેક્ચરમાં હું લઈ લઈશ. હવે નેક્સ્ટ ટાઈમનો લેક્ચર જે છે એમાં મેં ટાઈમ ચેન્જ કર્યો છે. મારે સેમેસ્ટર 4ની પણ સેમ ડે પરીક્ષા છે. સેમેસ્ટર 4 જે છે મારે 10:30થી સ્ટાર્ટ થશે તો 5:30 સુધી. તો 5:30થી મેં તમારું લેક્ચર એરેન્જ કર્યું છે. તો એ પ્રમાણે એ દિવસે તમારું લેક્ચર લેટ હશે. ઓકે, આનું પીપીટી મેં ગ્રુપમાં એટલે કે MS ટીમ ઉપર અપલોડ કર્યું છે. એકાદ બે રિએજન્ટ્સનું કદાચ બાકી હોય તો હું એ એડિશન કરી દઈશ, પણ હાલમાં તમારા જેટલા રિએજન્ટ્સ થયા છે એટલું તો કમ્પ્લીટ અંદર એડ કરી દીધા છે પીપીટીમાં, અને એ તમે રિફર કરીને વાંચી શકો. ઓકે, થેન્ક યુ. Now you can leave the meeting.